Solve a system of equations by elimination and graphing. This morning, a friend of mine, Paul, sent me a text message with a system of equations problem that he and his wife, Pierre, had worked out. And he asked me the question, did I solve this system correctly? Well, I look at it kind of like this way. If you solve a system of equations, get it right, you didn't do it wrong. It's kind of like that old commercial, there's no wrong way to eat a Reese's. Yeah, that's it. But what I'm going to do in response is show a couple of my favorite methods of solving this system of equations. And this is the problem that he gave me. So we have x plus y equals 35. And we have 4x plus 3y equals 134. What I'm going to do is solve by elimination. And the technique is to take one of these equations and rearrange it such that when you add to the other equation, you eliminate one of the variables. And what I'm going to do with this top equation is multiply it by -3 and then work to the right. So if we multiply this whole equation by -3, we get -3x minus 3y equals -105. And then we rewrite the second equation right underneath it. So we have 4x plus 3y equals 134. And so when we add these two equations together, we get -3x plus 4x is x, -3y plus 3y is 0, and we have -105 plus 134 is 29. So x equals 29. That's part of our solution. Now next, we're going to take this first equation, x plus y equals 35, and we're going to take this value of 29 and substitute it in back for x. And so when we do that, we get 29 plus y equals 35. And then if we subtract 29 from both sides of the equation, we get, just working the right here, y is equal to 35 minus 29, which is 6. So our solution is going to be x equals 29, y is equal to 6. And then you can substitute these values back into the original equations to check your work. Now, if you have technology available, there's another way to solve it by graphing. Also, you can use matrices by technology. But what we're going to do is rewrite these equations really quickly to be able to solve them quite easily in a graphing calculator. So what we have here is we take y equals, and you write 35 on the right, and the technique is called add or subtract the x term and then divide by the coefficient of y. Well, the x term is x, so we just have 35 minus x. Now, for this other one here, we have y equals, and you just put the number here, 134, and then you go ahead and subtract the x term, which is 4x, and then you wrap the 134 minus 4x in parentheses, then you divide by the coefficient of y, which is 3. And now you have an equation you can just put in the calculator, and this is what I did. And then if you graph this in a calculator, zoom 6, you get this, which you can't see anything, but if you change the window and make your x maximum appropriate, I'm going to put 40 here for my x max and 40 for my y max, and then graph, and we can see the intersection point, which means that we have our solution. And then you go to second, trace, 5, enter, enter, enter. And then you have x equals 29, y equals 6. So x equals 29, y equals 6. Now, one downside to working this way is if you work it this way and your teacher expects you to show work, you can work the problem this way and really not show any work to get it right. I hope this has been helpful. Good luck, and thanks for viewing.